We're going to add some definitions or some explanations on what we're going to get into. We're going to look at linear inequalities, excuse me. It's similar to what we've already done, which is linear equations. So write down, it's similar to a linear equation. But the equal sign that we have in a linear equation is going to get replaced. It's replaced with an inequality symbol. Oops, I need to fix that. When I mean inequality symbol, I'm talking about less than, greater than, less than or equal to. All of those symbols, greater than, equal to. And I'm just going to put those examples. Less than, greater than, less than, equal to, greater than, equal to. All right, so we're going to do what we've done before already with our last unit, our last 2 units. Meaning we're going to have y equals mx plus b. This is our linear equation in slope-intercept form. But instead of having the equal sign, all we're going to do now is put one of our inequality symbols. So it could be greater than in place of the equal sign. You're doing everything else the same. Does that make sense? All right, there's some rules that we're going to follow with inequalities, but I don't want you to think that, oh, we're looking at something totally new, because we're not. All right, so solutions of linear equalities. They're kind of similar to when we look for a solution for a linear equation. Looking at any point or order pair, oops, which is basically the x and the y, right? That will make the inequality true. I'm running out of room. Oh. Now, we've done this before with linear equations, with justifying answers, and that's just plug it in, plug it in. So we're familiar with that skill. We're going to check it with inequalities, though. So I'm going to let you get that down, and then we're going to determine if an ordered pair is going to be a solution to the system, which actually is to our inequality. Anyone still need the top part? All right, so here's our first check, or our first challenge. So we're going to practice determining if the point or the order pair is a solution. So we have the 0.73. Remember, we have the x and the y. So all we're doing is we're going to plug in its value into the inequality and then check to see if it's true or not. So instead of writing y, I'm now going to write what? 3. Yeah, 3 is less than, instead of x, I'm going to do 7 minus 1. And we're going to simplify that. We're just going to go ahead and do the subtraction. 7 minus 1 is 6, right? And it's 3 less than 6. Yes. Yeah, this is true. If we have a true statement, then it is a solution. Yeah. There's a solution. Okay? All right, so you are going to be responsible for 2 and 3. I'm going to come by and stamp, make sure everyone in your group has gotten the problem completed. Check with each other that y'all have the same answers, or y'all agree with the answers, y'all concur, and then I'll stamp based on it being right or wrong, okay? I'm going to give you a couple minutes to do that. Okay, guys, so here's a good use of showing work, how you get partial credit. Showed the substitution with the parentheses. This was false, or you could have said no solution. I would accept that too, true or false, okay? False was this one. And then same here, if you want to also show the multiplication and then how it simplified, this was true. 3 is less than or equal to, so it can equal to each other, and that was true. So good job on that. All right, so we're going to have another opportunity to present, and I'll do points for those as well. All right, so we're going to the next part. If you have a highlighter, you might want to get it out, because I'm going to tell you right now how to graph these 4 steps you need to memorize. You need to memorize these 4 steps, and luckily we already know the first 2 because we've done that. So we're just gonna add on 2 facts. All right, we're gonna rewrite in slope-intercept form. Guys, you need to get on this. No. Okay, here we go. Tyler. We need to first always get into y equals mx plus b form. This is just, you're going to graph that line. We're just going to kind of recap on the fact that, just making sure, because we had some issues with some graphing. You always start with the y-intercept, then you use the slope, that's your m, to plot additional points. I should see those additional points on your graph. I know the graphic calculator can do it for you, but when it says by graphing, I should see that you actually graphed correctly. All right, now this is the new information. You're going to have to determine the boundary line, okay? We have a boundary line when we're dealing with inequalities. If I'm talking about less than or greater than, it's a dashed line, okay? Notice that there is basically no equal to with those. But if I'm talking about less than or equal to, it's a solid line. The way I look at it, the way I break it down, okay, that symbol, no line underneath it. You do it all in one stroke, right? But if I do this right here, as soon as I put a solid line underneath the inequality symbol, now I'm drawing a solid line on the graph. Okay, so that's just a way to kind of remind you when you're going to do dash or. So if it's just a symbol, the inequality, that would be dash. But the minute I put the equal to symbol onto the inequality, it becomes solid. Now the next thing we're going to have to identify, and we're going to practice this, is whenever it's less than or equal to, we shade below. So basically when I see less than, something lower than, we're going below the line. But the minute I see greater than or equal to, now we're going above the line. I spelled that wrong. Yeah, I know, it looks bad. Alright, so these are the 4 steps we're going to do in class today. We're going to do a couple together, and then I'm going to check that you can do on your own. And there's some reasoning that you're going to do with your graphing. Alright, this is important. Let me just go ahead and make sure we signify, because we're going to hit that right off. Remember, if you multiply or divide by a negative, what do you have to do? You have to flip the sign. Flip that inequality symbol if you multiply or divide by negative. So we did that when we were doing simple inequalities on a number line. We're going to use that relationship still when we're graphing on a coordinate plane. So with that being said, let's look at number 1. We're going to practice the graph the linear equation inequality and state the solution. Let's check the solution algebraically. So first, we have 2x minus 3y is less than 12. So first, what do we need to do?
Minus 2x.
Yeah, minus the 2x. We got to get in slope-intercept form. All right, so write that down. Notice that the x's are on the left are going to cancel out. And then I'm going to rewrite what remains, which is a negative 3y less than negative 2x plus 12. So get that written down. We still have not solved for y yet. What's our next step?
Divide by negative 3.
Yeah, divide by negative 3.
So now flip the sign.
Yep, and now we have to flip that sign. So y is now going to be greater than 2/3 x minus 4. We have our equation in mx plus b form. So we have it in slope-intercept form. So that's our step 1. Step 2 is to graph using our y-intercept, our b, and using our slope to graph additional points. So on the graph, where are we going to start?
-4.
All right, put your point at a -4. So that's what I'm going to be checking for your graphs. I'm starting at the y-intercept. And now we move using our slope with plotting additional points. How am I going to move from our y-intercept?
Up to over 3.
Up to over to the right 3. 1, 2, 3. All right, so I'm going to repeat that. 1, 2, to the right 3. Up to 1, 2, 3 to the right. Or I could have went down 2 and to the left 3. All right, so do you see the additional points showing you the direction, the steepness of our line? Now, step 3 says determine the boundary line. In order to determine the boundary line, I have to look at my inequality symbol. I have to look at this to determine the boundary line. All right, so because we have greater than, it's going to be a dash. Yep, this is a dash line. So I'm just going to add some dashes in between my points. All right, so we have dashes. And then it says we have to determine the region, okay? The region of our shaded region, our solution set. So again, I have to look at the inequality symbol. Oops. So this symbol again was less than. So if I have a less than symbol, where do we shade? Greater, I'm sorry. Straight above. All right, so all I'm going to do now, you can do it with your highlighter or with your pencil. We're going to take this line, I'm going to look above it. Above it is here, and I'm going to shade everything above the line. Okay?
Do we have to like fill it completely or?
No, I just need to see the region. I need to know where it is, above or below. Okay? All right, now, to state the solution, well, let's think about this. We got to state a solution. We're going to check it algebraically. So, Sterling, where do you think would be a solution to this inequality? Take a guess. What do you think? A solution? Anything where, Alex? Anything above the line. Okay, give me something above the line. 3, 4. So if I look, I go over 3, up 4. All right, you see that point right there? Okay, let's check it. We're going to just check it algebraically. So I'm just going to do it over here. So we're going to check 3, 4 for our inequality. Y is greater than 2/3 x, minus 4. All right, so 4, is that greater than, let's do 2/3 times 3. What's 2/3 times 3? You have a calculator. It's just 2. All right, so we got 4 is greater than 2 minus 4. What's 2 minus 4?
2.
Try. -2. Is 4 greater than a -2? Yes, this is true. Now, so is that the only solution though?
No.
There's multiple solutions. Where would our solution be? Anything above in the shaded region, okay? Anything above in the shaded region. Now, what if I pick a point, let's say the point was at -3, -2 on the dotted line? Would that be a solution? Yeah, -3, -2. No, +3, -2, sorry. Let's check. +3, -2.
It's on the dotted line.
It's on the dotted line, but let's check it algebraically. Check it. So plug it in. Let me make some room. We're checking 3, -2, right? So
It's equal to.
yeah, but can we have it equal to?
No. Otherwise there would be a split line, right?
Yeah. So we have -2 is equal to -2. Remember, this is not, that's false. Because the -2 has to be, we're looking for solutions that are greater than a -2. No, you have to wait. All right, so flip it over to the next page. When you're done copying this, go to the next page because this is what you need to kind of memorize too. to identify your solutions. Alright, so what you need to know is when you have a solid line, the points on the line are solutions to the equations, the linear equation. So when it's solid, this is only when it's solid, okay? But when you graphing it, and that should be inequality, all points above well, not above. I say all points in the shaded region, because it depends on the inequality. All points in the shaded, because when we checked the point that was in the shaded worked. Now here's the test point, which is a good way to check. A test point is any point in the shaded area, okay? Basically, you're just going to see if it makes the inequality true. You can just test the point that you see in the shaded region, check to see if it makes it true. Points on the dotted line are not solutions, okay? Points on the dotted line are not solutions to the inequality. All right, so let's check, make sure we can graph correctly. On number 2, how are we going to graph x minus 3y is greater than or equal to 6? So we're left with negative 3y is greater than or equal to negative x plus 6. Divide by negative 3. Y is less than or equal to, got to flip the sign because we divide by negative. 1/3 x minus 2. So now we have our equation in slope-intercept form. That's the first step. So now we got to graph it. For this inequality, we start where? Negative 2. Put a point on negative 2. And we are going to move
Up 1 to the right 3.
Yeah, up 1 to the right 3. 1, 2, 3. Up 1 to the right 3. Or we could go down to the left 3. 1, 2, 3.
And this one would be a straight line, right?
Yeah. Why is this one going to be a solid line? Because the equal to part, yeah. Because that solid line underneath the inequality. So we are going to have a solid line. My line is crooked. Apologize. Okay. All right, and where are we shading? Where are we shading?
Above.
We're shading above?
No.
Read the inequality. What is it? Read it. What does it say? Why are we shading below? Because it says less than or equal to. So we're shading below.
Oh my gosh.
We're shading below, huh? No, I'm not gonna ask you to check right now. You're gonna check it on the next one. So graph number 3, and then they'll ask you to check on the remaining questions. So I'm gonna give you time as a group to graph 3 and to do the questions, the 3 questions at the bottom. That's the checking part. I've already gave you some points to check with. I'm gonna give you some time to do that.
Okay, guys.
All right, let's see. I think checked your graph and you had the following. We had a dotted line because we had just a less than symbol, and because it's less than, we're shading below. So I checked and y'all, majority of y'all had that. That's good. So we're going to answer these questions is use a graph from number 3 to answer the following questions. Is the point 0, 0 a solution to the inequality of the graph? So I just got to look at the graph and then check to see if that point 0, 0 is in the shaded region, and it is. That would be part of the shaded region. So number 4 is yes. And then if we look at number 5, is the point negative 4, positive 3 in the solution. So if I go to negative 4, positive 3, that's over here. That's not in the shaded region. So that is no. And this is the point -2, 0 solution to the inequality graph. So if I go to -2, 0, -2, 0 is on the dotted line. Okay, I know it's one of the points we use to plot the line, but it's on the dotted line, so this would be no as well. All right, so make sure you have this in your interactive notebook for me to check on Monday. One page, the first page should be on the left side, and then the second page should be on the right side of your interactive notebook. I'm going to be checking that you have your foldables, you have the notes that we've been doing for the last unit, and then it should be easy daily grade. And make sure you do your problems in your workbook, page 170 through 166, excuse me, to page 170. It goes to what we just did on our notes on this blue sheet, graphing linear inequalities, checking that you do the correct line, you have the correct shading, you can determine the correct solution. All right, thanks guys.